Hi, question one. How many phosphate ions are there in 103.39 gram of calcium phosphate? So, molar mass of calcium phosphate is given. So, let's start with first writing the formula of calcium phosphate. So, in 1 mole of calcium phosphate, we have 3 moles of calcium ion, and we have 2 moles of phosphate ions. Okay, we know N is equal to m over molar mass. The mass given for calcium phosphate is 103.39 divided by the molar mass is 310.18. If I solve this, this will give me 0.333 moles of calcium phosphate. But we have to work with the moles of phosphate ions. In 1 mole of calcium phosphate, there are 2 moles of phosphate ions. So hence we need to multiply the moles of calcium phosphate with 2 to work with the moles of phosphate ions, and that gives us 0.666. And let's look at the options. So option C, if we round it, 0.67 is the correct answer. Question number 2. Balancing the chemical equation using the smallest whole numbers and telling the coefficients. Okay, so if we look at, we have 1 mole of iron sulfide, we have 2 ions on oxides. If I put 2 here, iron is balanced, so to balance the sulfur, I will put 2 from sulfur dioxide, so sulfur is balanced. And on product side, we have 7 oxygen at the moment, so if we put 3.5 here, so oxygen is balanced as well. But we need to balance this equation with the smallest whole number. So if I multiply everything with 2, then I will have 4 iron sulfide, I will have 7 oxygen molecules, I will have 2 iron oxides, and I will have 4 moles of sulfur dioxide. So we have 11 coefficients on reactant side, and we have 6 coefficients on product side. And if we add them together, so we will have 17 coefficients. So hence D is the correct answer. Question 3. What is the yield of sodium chloride in grams? 4.60 gram of sodium react with 1.14 dm cube of chlorine gas at STP. So let's start working the moles of sodium first. So 4.60 divided by 22.99 is the molar mass of sodium, and we solve it, that will give us 0.200 moles of sodium. We can work with the moles of chlorine. We know N is equal to V over 22.7, so V is given in dm cube, so 1.14 divided by 22.7, and that will give us 0.050. So 0.050 moles of chlorine. The ratio between sodium and chlorine is 2:1, so chlorine is a limiting reactant. Chlorine is a limiting reactant, so the ratio between chlorine and sodium chloride is 1:2. So the moles of sodium chloride will be 0.050 times by 2. That will give us 0.100 moles of sodium chloride. We need to find the mass. So mass is equal to moles times molar mass. And the molar mass of sodium chloride is 22.99 plus, look in the periodic table, so Cl is 35.45, and that will be 58.44 gram per mole. So if we multiply the moles of sodium chloride with 58.44, and they will give us the mass, which is 5.84. Hence option C is the correct answer. So limiting reactant question. Question 4. What is the pressure in Pascal inside 3.0 dm cube cylinder containing 64 grams of oxygen at 25 degrees Celsius? R is equal to 8.31 joule per Kelvin per mole using ideal gas equation PV and RT. So let's rearrange for pressure. So pressure will be equal to nRT over V. Let's do the unit conversion. So temperature has to be in Kelvin. So T will be equal to 25.0 plus 273. That gives us 298 Kelvin. Volume has to be in meter cube. So 3.0 divided by 1000, or we can say 3.0 times 10 to the power minus 3 meter cube. Okay, let's find out the moles. N is equal to mass over molar mass. So mass is 64, molar mass of oxygen 32, give us 2. Substitute these values in the equation. So 2 times 8.31 times by 298 divided by 3.0 times 10 to the power minus 3. So let's look at the options. No, temperature is in degrees Celsius. Okay. Volume is not converted into meter cubes. So B is the correct option. Question 5. Finding the AR of an element. This question can be answered in two ways. The first way is using the formula. So AR will be equal to relative isotopic mass of first isotope times by its abundance plus mass of second isotope times by its percentage abundance divided by 100. If we solve this, that will come as a 10.2. But this question can be answered without using a calculator. So how can we do that? So the mass of 10 is much more abundant than the mass of 11, which is 19.9. So our AR should be slightly higher than 10. So let's go through the options. So option A, 10, no, it doesn't show any contribution of 11 at all. And same way we can eliminate D because it's close to 11 and doesn't show any contribution of 10. And from the rest of the two options, 10.2 is very close to 10. So hence option B. So both ways this question can be answered. Question 6. What is the correct for the wavelength and energy of the radiation of ultraviolet and visible region of electromagnetic spectrum? So we know wavelength and energy, they are inversely related. So wavelength and frequency, they are inversely related, and frequency and energy, they are directly related. So higher the frequency, higher will be the energy. Higher the wavelength, lower will be the frequency and lower will be energy. So UV radiations, they have high energy, high frequency as compared to visible. So UV, and then we have visible. So UV will have high frequency as compared to visible. So visible will have low frequency. So visible will have high lambda and UV will have low lambda, low wavelength. And visible will have low energy and UV will have high energy. So let's read the statements. So option 1, lower wavelength and high energy, which seems right, and higher wavelength and lower energy. So A is the correct option. No need to read the rest. Question 7. The graph represents the first 10 ionization energies of an element. What is the element? So if we look in the graph, so 1, 2, 3, 4, 5, 6 electrons are moved, and then there's a jump. So that means our element is in group 16. It has 6 electrons in outer shell. So group 16. Group 16. Let's narrow down the choices. So chlorine, no. Neon, no. So that leaves us between oxygen and sulfur. Oxygen will have maximum 8 electron, but we have been given the 10th ionization energies of an element. Hence, oxygen is not the option. So the correct answer is sulfur. Question 8. Which statement correctly explains the difference in color? So we have been given 2 complex ions of cobalt, and one of them is blue while the other one is pale yellow. Before answering this question, so let's revisit what are the factors that affects the color of metal ion complex. So is the identity of metal, oxidation state of metal ion, coordination number, shape of complex ion, and identity of ligand. So let's start reviewing these statements. So statement A, the ligand cobalt cyanide is weaker and absorb light of higher frequency. No, the weaker ligand should absorb a light of low frequency, hence this statement is wrong. The oxidation state of cobalt is different in each complex. So let's work out. So oxidation state of cobalt in first complex is +3 because water is a neutral ligand. And in the second one is also +3 because cyanide is negatively charged ligand, so -1. So oxidation state of cobalt is different in complex. No, that is wrong. So oxidation state is +3 in both of them. The different colors are due to different charge in the complex ion. So the charge doesn't matter. It's not the factor that affects the color of metal ion complex. So that statement is wrong. So that leaves us D as the correct answer. But let's read. The ligand cobalt cyanide causes larger 3D orbital splitting and absorbs a light of higher frequency. Yes. So greater the splitting, a higher frequency will be absorbed. So cyanide ligand is a stronger ligand and it causes greater splitting. Question 9. Which of these period 3 oxides forms a solution less than 7 when added to water? Aluminium oxide, amphoteric. So no. Magnesium oxides form magnesium hydroxide, so greater than 7. Sodium oxide dissolved in water forms sodium hydroxide, so greater than 7. And that leaves us option D as the answer. Oxides of non-metals, when they dissolve in water, they produce acidic solution and pH less than 7. Question 10. Which configuration is that of transition metal atom in its ground state? So A, we have neon 10, 12, and 6, 18. So is argon? No. Is a noble gas. B, it looks like a transition metal, but is ion because 4s is empty. So no, we're looking for transition metal atom. C, no, is not transition metal. It's in P block somewhere. And that leaves us D as the option. And D is 18 plus 1, 19 plus 5, so 24, and that is chromium. So chromium has 4s1 and D has 5. So D is the answer.